हेलो फ्रेंड्स, वेलकम यू ऑल हियर। यदि आपने अब तक हमारे यूट्यूब चैनल को सब्सक्राइब नहीं किया है तो अभी दबाएं सब्सक्राइब बटन को। इसके बगल में दिए गए बेल आइकन को दबाना न भूलें ताकि हमारे सारे नए वीडियोस आपको सबसे पहले देखने को मिलें। धन्यवाद।
हेलो स्टूडेंट्स, आज हमारा ये वीडियो क्लास का चौथा दिन है और आज हम क्लास 10th के लिए रियल नंबर्स चैप्टर नंबर 1 और एक्सरसाइज 1.4 से रिलेटेड कुछ हम स्टडी करेंगे। टॉपिक है रिविजिटिंग रैशनल नंबर्स एंड देयर डेसिमल रिप्रेजेंटेशन। So students, first of all, I want to recall the rational numbers. One thing you had studied in class 9, any number of the form P upon Q, where P and Q are integers and Q should not equal to 0. This is first definition. Any number in the form of P upon Q. Second one is all the terminating decimals. You can see terminating decimals. Suppose 0.375, 17.251. So you can see both are terminating. First number is terminating after 3 places of decimal. Second number is also terminating after 3 places of decimal. So both are rational numbers. Here about the number which are in the form of P upon Q. Suppose number is given this, another number suppose 25 upon 7. So both are, you can see, rational numbers. Now one more type of number also, those are non-terminating repeating decimals. So you can see there are 3 type of rational numbers, either in the form of P upon Q or in the form of terminating decimal or non-terminating repeating. For example, I would like to explain. Suppose 5.123 dot 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 123 repeats many times. So this number never terminate, means non-terminating. Repeating means set of numbers are repeating. 5.123 you can write like this. This number can be expressed as this one using one bar. One thing, I am taking one question. Represent 0.375 in the form of P upon Q, where P and Q are integers and Q is not equal to 0. You can see this number is given in the decimal form. So 0.375, this can be written as 375. After decimal place, 3 decimal place, number is terminating. So make 3 zeros and 1. So now number is in the form of P upon Q. Sometimes it is needed to write in this form 375, and you can convert it in the form of its prime factorization. So see how to do its prime factorization. 1000 can be written as 10 into 10 into 10. Now easy to find prime factorization. Every 10 can be written as 2 into 5, 2 into 5, 2 into 5. It is easier way to find the prime factorization of 1000. Now you can rewrite it as in the form of raised to the power. You can write it as 2 raised to the power 3 and 5 raised to the power 3. So students, question is coming without actual division, without actually dividing. How you will find the type of the number? This number is terminating or non-terminating, repeating, which type of number it will be. So in exercise 1.4, question number 1 is of the same variety. In that question, some fractions are given. You factorize. First of all, you write the numerator and denominator in the form of co-prime. They should not have they should have only one as common factor, no other number as factor. After that, you will factorize the denominators as I have done here. You can see the factor of the denominator is 2 to the power 3, 5 to the power 3. So related it, one theorem is given. I would like to just after explain about the theorem. That theorem is saying that if any number is written in the form of P upon Q, where P and Q are co-prime, and if you are factorizing the denominator Q, and prime factorization is coming 2 raised to the power n into 5 raised to the power m, and nm are whole numbers, then the number will terminating. The decimal extension of the number will be terminating. So now see the theorem. See theorem 1.5. Let x be a rational number whose decimal expression terminates. You know already. Then x can be expressed in the form P upon Q, in the form P upon Q where P and Q are co-prime. I want to focus this word co-prime, and the prime factorization of Q is of the form 2 raised to the power n into 5 raised to the power m, where n m are non-negative integer. The meaning of non-negative integer means positive integer as well as 0. So in one word we can write whole numbers. N and m both are whole numbers. So see the meaning of this. Suppose one number is written here. If you are knowing this theorem, so you can say about this number is terminating. Why? Because this can be converted in the form of P upon Q. Here you can see the numbers are not co-prime. So first you will write in the form of co-prime. If you can simplify it, so just simplify. So you can see it is divisible by 25. 25 40 ja. And this can be also divisible by 25 1 ja 25 and 12 is remainder, so 25 5s are. So you can see number is coming 15 upon 40. Again you can see you may further simplify because numerator and denominator are not co-prime. So again divisible by 5, 5 8 ja and 5 3 ja. So ultimately its fractional representation is 3 upon 8. Now we are going to factorize and to check the prime factorization of denominator is coming in this form or not. So I am going to write its prime factorization 2 raised to the power 3. You can see 5 is not here. It means 5 is not present, so 1 is here in the product. You can write in the form of 5 raised to the power 0. Now you can see about this theorem. This theorem is saying first, if you are knowing the number is terminating, then x can be expressed in the form of p upon q. This is in the form of p upon q. Then where p and q are co-prime, then the prime factorization of q is of the form this one. You can see it is coming because this number is terminates after 3 places of decimal, and its fractional representation where numerator and denominator both are co-prime, then its denominator will be of the form 2 raised to the power n into 5 raised to the power m, where n and m both are whole numbers, or you can say non-negative integer. So students, concept is clear what this theorem is saying. Means without division you can do like this, adopt this process and see the denominator. If denominator is coming in this form, whatever is written here, then you can say about the number is terminating and its decimal expression is of the denominator is in this form 2 raised to the power n into 5 to the power m. So students, this thing you will do in question number 1, exercise 1.4. See theorem 1.6, converse theorem of the 1.5. Previous theorem and this theorem both are inverse of each other. You can see let x is equal to p upon q be a rational number such that prime factorization of q is of the form 2 raised to the power n into 5 raised to the power m, where n and m are non-negative integer. Then what will happen? X has decimal expression which terminates. Now I would like to explain it with taking very small example. Suppose the number is written here 23 upon 2 raised to the power 5 into 5 to the power 5 raised to the power 2. So according to this, x is in the form of p upon q. You can see numerator and denominator both are co-prime. Now check the denominator. You can see denominator is in the form of 2 raised to the power n and into 5 raised to the power m. Here n and m are whole numbers. It means which type of this number will be? This number will be terminating decimal. So without actual division you can identify given number is terminating or non-terminating, repeating. Just you can see this is the converse of the theorem 1.5. Now see theorem 1.7, which is last theorem of this exercise. See, let any number x is in the form of p upon q, where p and q are co-prime. It be a rational number such that prime factorization of q is not of the form 2 raised to the power n into 5 raised to the power m, where n m are non-negative integer. Then x has decimal expansion, which is non-terminating repeating. See the meaning of non-terminating repeating, recurring decimal. Is it clear? No, otherwise, I would like to take one example. Suppose there is a number. See exercise 1.4, question number 1, seventh part. Question is given 129 upon 2 square into 5 raised to the power 7, 7 raised to the power 5. You can see the number is written in the form of p upon q and prime factors of the denominator is given. You can check it. This is, you can see this theorem. Here is written q is not in the form of q is not in the form of 2 raised to the power n 5 to the power m. Here one more factor is coming. If it is not present here, then you can say this rational number is terminating decimal. But if it is not in this form, some other factor also involved, then this type of number will be non-terminating repeating, or you can say recurring. So question number 1, I would like to say some more about it. I am going to read question number 1. What is full question? Without actual performing the long division, as I have done, state whether the following rational number will have a terminating decimal, expansion, or a non-terminating repeating decimal expansion. So student, all these questions are of the same variety. You just see one question related to same pattern. Question number 1, ninth part. See question number 1, ninth part. It is given 35 upon 50. So see its solution, what you will do in this question. 35 upon 50. Now first of all, your work is you write the both one in the co-prime form. So you can see both are divisible by 5. So 5 10 ja, 5 7 ja. So number is coming 7 upon 10, and now you can write 7 upon 2 into 5. Now you can see their powers are 1 1 each. So what is, you will write here, since denominator is of the form is of the form 2 to the power n into 5 to the power m, where n m are whole numbers. Therefore, this number is terminating decimal. you can say its decimal expansion is terminating. So in this way question 1 ninth is over. Here one thing is given, either the number is terminating or non-terminating decimal. So you check one by one all these using the same method. In some questions already factors are given. If prime factor of denominator is not given, you must find. But don't forget numerator and denominator both should be co-prime. Means only one should be common factor in both numerator and denominator. No other prime factor should be common. So convert the number as here I have converted 35 upon 50 converted in the form of P upon Q. No common factor other than 1. After that we will factorize the denominator in the form of 2 raised to the power n, 5 raised to the power m. In this way you will decide the type of the decimal expansion. So here you can see in this form, so the number is terminating decimal. So question number 1 finish. There are 10 parts in question number 1. You do all these one. Questions exercise is given. Number 2. Write down the decimal expansions of those rational numbers in the question 1 above which have terminating decimal expansion. So student, you can see this number. I have taken question number 1 second part for on the behalf of question number 2. So question number 2 is totally based on question number 1. You will see all the part of this one, those are terminating. You can rewrite it as 17 upon 2 cube. Now you can see denominator is in the form of 2 to the power n into 5 to the power m. Since 5 is not here, it means 5 raised to the power 0 present here. So without actual division you can write its decimal expansion. How? You just see this can be written as 17 upon 2 raised to the power 3. How power of 2 is here? Same number of power of 5 you will multiply numerator and denominator. Here 2 raised to the power 3. So here you from your side you will multiply numerator and denominator by 5 raised to the power 3. Now you can see there will be no change in the rational number and you can do this work very easily. You can see 17 into this one is 125. Here you can write 10 raised to the power 3. 10 raised to the power 3 means how much? 1 followed by 30. Just check it is correct or not. Yes students, it is correct. Now you can without division 3 places of decimal you start from this unit place digit. So you write the number and check where you will put the decimal. 1 2 3 1 2 3. Where is 1? You put the decimal. So how much places of decimal this number terminates? This number terminates after 3 places of decimal. And here we have not done actual division, just applying the technology and you can find its decimal expansion. So student, one more thing is coming in the board examination. Just after I will explain. So now see the question number 1 8th part also. You can see both are not in the simplest form. You can divide the numerator and denominator by 3. 3 2 is 6. 3 5 is Now you can rewrite it as in the form of 2 upon 5. So you can see decimal expansion of this rational number is required. You can rewrite it as, we want its decimal expansion. So how much 5s are here? Only 1. So you will also multiply numerator and denominator by same 1. 1 power never write, but I am writing here for your clarification. Now you can write the denominator as 10. Now multiplying 2 into 2, 4. So you can see the decimal expansion of this number is 0.4 answer. So student, one thing I would like to tell you, without division you can say in how, after how much places of the decimal the number terminates. No need of division, just you can say in after how many places of the decimal number is going to terminate. Just see the factors. If number is terminating, here is given like this. Here what number is given? No problem. Any number is given. You just see this one. If the factor is in the form of 2 to the power n into 5 to the power m, you see maximum power. You can see either of 2 or of 5, which has maximum power. You can see 2 has maximum power 3. So this number will terminate after 3 places of decimal. So concept is clear to all. After prime factorization of denominator, you check either of 5 has maximum power or have 2. So in this case 2 has maximum power 3. So what is maximum power in 2 and 5? After same number of place, the number will terminate. One more example I would like to tell you. 7113 divided by 2 raised to the power, suppose here 7 is written and here 3 is written. Now concept is clear. You can see decimal extension of the denominator is this one. Here what is maximum power of 5 or 2? In both 7 is maximum power. So if you will divide this number by denominator, this number will terminate after 7 places of decimal. So student, no need to actual division. You just see the power of 2 or 5, which one is greater. Same number of decimal places, the rational number will terminate. Okay students, so this is question number 2. You can do totally based on question number 1. Question number 3. The following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational and of the form P upon Q, what can you say about the prime factor of Q? Question number 3. After observation, this number, you see which type of number. You can see it is rational or not rational. So you can see this number terminate after 9 places of decimal. You can see after decimal 9 digits are there. So this number is of which type? You can see this is terminating. And you know all the terminating decimals are which type of number? Since this number is terminating, so you can say this number is rational. One more question is added here. If the number is terminating, so if you are going to write this number in the form of P upon Q, say about this Q prime factors. So you can see this number is terminating decimal. It means you can say its prime factorization will be of the form 5 to the power m, where n and m are whole numbers. So student, you can see question 3 first part completed. You just decide this is terminating decimal. So your answer you will write like this. Number is terminating, therefore it is rational number. And its denominator you can write it in the form of P upon Q, and the prime factor of Q will be of this form. Because it is asked in the question, you must write your answer. So now see the second one. Second question you can see 12.0.2000 and 1250 and so on. So you can see this number is non-terminating, non-repeating. So you can say this number is not rational. You can see easily non-terminating, non-repeating or numbers are not rational, or you can say irrational. What is this number? This number is irrational. Why? Reason is given, non-terminating, non-repeating. So answer you can write either not rational number, or you can write irrational number. So no need to see you cannot express this number in the form of P upon Q. So no need to write like this about it. If number is terminating, then you will write which form denominator will be there. Now next thing. Third part. 43.123456789. You can see this number is recurring decimal. Either I am saying recurring or non-terminating repeating. Non-terminating repeating. So you can easily say this number is rational, because in the beginning I illustrated the definition. This number is rational. It means you can see if you are writing this number in the form of P upon Q, it will not in this form. Because it is asked, this number will be of the form 2 to the power n into 5 to the power m or not. So your answer will be no. Its denominator will not in this form. So exercise 1.4 dear students completes, and मुझे उम्मीद है कि आज आपको ये चौथा क्लास है, क्लास 10th का पहला चैप्टर आज ही कंप्लीट हो रहा है। मुझे पूरी उम्मीद है कि आप लोगों को ये अच्छा लगेगा, काफ़ी ज्ञानवर्धक रहेगा, और मैं चाहूँगा कि स्टूडेंट्स आप अपने रिलेटिव्स और अपने अन्य फ्रेंड्स को ये लिंक भेजें, जिससे इस लॉकडाउन में वो अपने इस चैप्टर की तैयारी ठीक से कर सकें। ये एक्सरसाइज 1.4 आज कंप्लीट होता है और इसी के साथ पहला चैप्टर आज हम कंप्लीट करते हैं। तो फिर अगले वीडियोज़ के साथ फिर मिलेंगे। जय हिंद, जय भारत।